build my own pipelines and figure things out. So glad that there are good tools out there now to make things offload a lot of that
Build my own
brain power.
pipelines and figure things
Okay.
out. So
Okay, I think we are live, which is cool.
Nice.
Um, Let me just do a couple things.
Great.
We don't have a full like team to do stuff for us. We gotta update Reddit at the same time as we do this.
I think it's great.
Cool. Well, this is gonna work. Okay, awesome. So let's get going. Jeff, we're super excited to have you here. And just to kind of dive right in, you've said before you're not a fan of the term RAG. I want to kind of hear more about that. Everyone in AI seems to be using it. What bothers you with it?
And there's a lot to not like about the term rag. Number one, the aesthetics of a rag are already just sort of a bad, starting spot. I think also rag is, yeah, as you know, an acronym that is retrieval augmented generation and like is a blending of concepts, right? It doesn't really mean any one thing. Is it about context augmentation? Is it about in-context learning? Is it about next token prediction? Is it about like, search? Is it about dense vector search? I think the part that I don't like about it is that it doesn't really mean anything, or can mean everything. And like that just makes it a bad term. And it makes it a term that like can both embody everybody's like all people's hopes about what the technology can be. And so like, you can use RAG as sort of a stand-in for almost artificial super intelligence in some communities, right? It's like just sort of this like panacea, if you will. And then you can also use the term RAG as a pejorative, right? You see other communities, they're like, RAG sucks. All you need is regex search, right? And you're like, I'm pretty sure it's still RAG, like it's still
Yeah.
retrieval-augmented generation. And so like, yeah, I think my qualms with it is that it doesn't really mean anything. It also implies like a one-time, one-way data flow. Like we're gonna take our data from here, we're gonna embed it, maybe we're gonna put it over here, and we're gonna be able to search it, and then we're done. And like, I think that's not the job, right? Like, as anybody who's built something real will tell you, like, the job of like context engineering, which I think is like the better term, is like a labor of love. Like all software is a labor of love. What do? You build the software, you figure out where the bugs are, you try to fix those bugs, you figure out what other features users want, you try to add those features, and you do that for like years and years. And like that's what software is. And so like I think like thinking about like the practice of building great AI systems as more of like this like software labor of love is the right way to think about it. And again, RAG, I think is like too static of a term. So these are all my qualms. Yeah.
You kind of dropped this term context engineering. Tell us more about that.
I mean, I didn't invent the term. I maybe helped spread it a little bit. Prompt engineering was sort of the dominant term for a while there at the beginning. And like, I think that is a useful term, but it was very like system prompt centric, right? It was sort of like, oh, just like fiddle with your system prompt. You saw tons of startups pop up that were like, will help you fiddle with your system prompt. I think in my view, like AI is quite simply just a new kind of computer. It allows us to run unstructured programs. And the information that's in the context window is the programming of the system. And obviously that includes, yes, the system prompt, but also includes, information that is dynamically searched for and retrieved. It includes user memory, it includes logs and traces, it includes, conversation history. It can be like many things can be in this in the context window. And so like the job is not simply to iterate the prompt, and the job is to iterate like the context window writ large. And so, I think context engineering again is like the right term. Like context engineering implies the existence of a context engineer, which I think that's the job to be done. Maybe it also implies the existence of a context engine, though I wouldn't say anybody's figured that out quite yet. And yeah, so
The thing I like about it is it sounds more complex than RAG. And many people I chat with that are just starting on a RAG project, they're like, hey, this is easy to do. I just like hook up a few things and I can retrieve. It seems like it's good. I put 10 items in a pipeline and I can retrieve them. Like it works. And reality is,
Yeah.
search is hard. Like has
Yes.
been hard historically, and companies like Google, exist
Yes.
because of search.
Yeah, I think
What's
that's
different
a
about AI search and, what
yeah.
makes it hard at scale?
I think a really, really good point, which is also like context engineering implies the correct level of difficulty and importance versus RAG, it implies that it's too easy, if you will. And so I think it's also important to like raise the status of the job, like you probably don't want to put on your LinkedIn. I mean, this is like the RAG subreddit, but like, you probably don't want to put on your LinkedIn, RAG developer, on your LinkedIn, but like context engineer on your LinkedIn or like, software engineer dash, context engineering, something like this. Like that is like a high status job and it deserves to be high status because it's difficult and important. Yeah, I think that, the differences between like classic human search and AI search are many and very fascinating to like unpack and unravel. I think that the simplest difference is like, human search tends to be like a Google search, right? You type in like three or four like words. We've all been trained in our brains like how to Google because we've tried things that didn't work, we've tried things that have worked, and we had our, a long time ago, we sat next to our friend who showed us how to Google when Google first came out, and you kind of learn how to like string together like four or five like lexical keywords to like try to find something, right? To like learn the skill of like this. And like AI search ends up being like, and we're always looking for like one document, right? When you're using Google, you're looking for like one thing, really. One page typically has the answer you want. And AI search is much more open-ended. Like these queries can be like much longer, much more complicated, much more just natural language. And like you might need to like find 20 pieces of information and like read them all together to like create the answer that you want. And so like there's a bunch more I could say, but like there's maybe to start off, like I think there is like this like large like secular shift happening in like search workloads, and it is like this shift from like human centric search to like AI or agentic centric search.
Yeah, makes sense. And to kind of like make it clear in a Google search, obviously you're like searching the web, which over time became more organized with sitemaps and so on. And here, with a lot of what folks are doing, their internal data, so on, which is super unstructured.
Mhm.
So maybe tell us like a bit more about that and how you've thought about that as you started building Chroma.
Yeah, I think this also kind of maybe kind of dovetails into like the idea of like search like strategies or search probes, retrieval strategies, retrieval probes. Like, there probably is not like one approach which is a panacea. The reason that I think like dense search is so powerful and embedding-based search, semantic similarity, vector-based search is because for lexical search or full text search, you have to know the grammar and the corpus of what you're searching. So, if I'm searching my Google Drive and I'm looking for a given document, I know exactly what to search for because I made that document, usually. I know like exactly what word to search for. And so actually like lexical search is a great tool in the toolbox. If you know exactly what you're looking for, you know an exact word or exact number. But if you're looking for something you don't quite know how to put your finger on, and you don't know quite how to express, then like you kind of want that like semantic expansion factor that like dense semantic similarity based search can give you. And so like some use cases will be primarily sparse or lexical and very, minimal percentage of dense. So like you actually see this with like enterprise search typically, like kind of your classic, search box across all of your different data silos in your enterprise. Like they tend to be like heavily skewed in terms of like the number of results and the click-through rates, heavily skewed towards lexical, and like dense is not a big factor. But with AI, like if your AIs are writing the queries, your AI is not typically the system that originated the document, nor does the AI like remember. AIs are stateless, right? Like LLMs are stateless. The LLM doesn't remember it made the document. And so like I think that the dense search then is a very useful tool in the context of AI. For that reason, Secondarily, it's very useful because now with a lot of applications, you're giving end consumers or prosumers the ability to like say ask for whatever they want in a box, a magical box on the landing page. And so like in that world, you need to be able to translate whatever that user is saying in their own words into like the right resources that you need to solve that problem. And so again, like the dense embedding search semantic expansion is like a very powerful tool. So this is, I think, like, this is why, like, dense, this is one reason about, think about, like, why is, like, vector-based search so popular now versus, like, not as popular, like, 5 or 6 years ago. And I think it's because, like, again, like, the use cases and the user has changed to some degree. But yeah, there's a lot more to say, but I'll pause there.
Awesome. We have some questions in the RAG subreddit as
Great.
well. Um, and one of them is, so what were the hurdles when writing the code, which became Chroma DB, especially knowing everything you just talked about with dense search and memory and things of that nature?
Mm. Yeah, the hurdles were many. We write about a bunch of this stuff on our like engineering blog. Um, but maybe I'll zoom out and, kind of try to share what our goals were. So we always care so much about like the developer experience of the thing. Like it just needs to be like so easy to use out of the box and powerful out of the box. But then also needs to give you the ability to break glass when you need to and break out of that box and, do the thing you need to do for your use case. So that's the first priority. The second priority is making a system which is also easy to scale and easy to run.
Hmm.
So many times the database becomes a thing that's like, falling over in the
Right.
middle of the night, or the queries are slowing down, or the bill is blowing up, or like it's like these degenerate pathological cases. And of course, your database is like your stateful part of your system. And so like that going down and that losing data is, cataclysmic, right? Like you like don't want that to happen. And so like what we worked on basically was this distributed and serverless version of Chroma that like was extremely easy to scale and therefore very easy to reason about. And we basically like, don't think that developers need to like be on call for their database. There's like no
Right.
reason that should be the case. And like they shouldn't really even need to think about it. And actually recently we had a customer who on Twitter was talking about this. They like launched and it was like super popular launch and like their Postgres database was going down, their like compute infrastructure was going down, but like Chroma, they didn't think about it at all because it like just kept kind of steaming along.
That's
That was
fantastic.
a awesome like you build something, you hope that people will see the value in it, and like that was really cool to hear them talk about that. We also really prioritized like cost efficiency and so
Yeah.
making like it as cheap as possible because I don't know, it's just like memory is really expensive and obviously vector search is very memory dependent. And so there's a bunch of detail here, but basically we built out a system where the data mostly lives on object storage. And then when it needs to, it'll be paged into memory to serve queries.
Okay. Yeah.
Then we also use heavy disk caching on NVMEs as sort of a middle layer, warm tier, to make up for some of the cold start semantics of object storage. So this natural kind of TTL waterfall of like keeping the data only as fresh as it needs to be enables extreme cost efficiencies. And that also in the context of a multi-tenant system where many users are time sharing their workload over the same
Hmm.
pool of nodes means that people only pay for like the tiny slice of compute that they use, at that exact point in time. And no one has to like buy a server, out of the gate, basically, right? And so, anyways, to accomplish all of this, there's like so much technical work.
Yeah.
We even invented like a Reddit headlog on S3. We have a deep dive blog post about that on our blog. And so, the number of like technical hurdles I would say to like get to this state were many. And really it was all in the pursuit of like great developer experience. Like you should be able to build locally, deploy to prod, scale super effortlessly and cost effectively in prod and like never have to think about it. Which I think again, like you almost like can't do if you don't like put in like this like sort of fundamental work. So yeah, the problems were many. We can get into more detail if you're interested, but like yeah, that's kind of the
Yeah.
high.
We'll post the link to the dev blog after the fact for people to read as well.
Cool.
Um, well, that goes into another question on here, which is it goes a little bit into the future. It seems like every day there are 12 new platforms, RAG frameworks being announced, open source, some closed. What do
Yeah.
you see happening over the next 6 months in terms of this recent explosion of platforms, projects? What factors do you think are going to decide what sinks and what swims? That was from member Blue Jeans 37.
It was really hard to predict.
Yeah,
Um, I think like, oftentimes what makes sense for the next 2 weeks is easy. What makes sense for the next 10 years is easy. What makes sense in 6 months, that's like kind of a death valley of predictions. Really risky. But I mean, the North Star is always like, is your framework solving a hair on fire problem that like a small number of people currently have, but a huge number of people will have in the future? I think it's always like a good way to think about it. Number one. Number two, is your framework or project solving that in an elegant fashion that like, people are excited about basically? And then number three is like, distribution is not free and like, can you get the word out, fast enough to kind of consolidate enough of the traffic on like your particular approach or solution. So this is really a framework of like, are you
yeah,
solving a problem, at a core level, that matches the market and its explosion? Can you get the DX right? And then can you get the marketing right? You can have a dumb framework, right? But that's sort of like a broad framework, true about anything, not just RAG.
right.
I think with RAG specifically, we already talked about it a second ago, but like, or context engineering, if you
Mhm.
will, or just search for AI, right? It seems again like one of the most interesting trends is like maybe it's sort of like the bitter lesson here, which is like,
Mhm.
to what degree is like search and retrieval going to be like folded back into the model?
Right.
Like the planning around that going to be folded back into the model. And right now we have like very exotic pipelines often where we do like query in, query expansion,
Yeah.
this, that, the other, re-ranking, checking policies, re-ranking again, like this like complicated system. And like I think the kind of an interesting question is like, again, to what degree is that just going to get folded back into the model? I think that like indexing and search will always be a useful primitive to have outside of the model. But like, there's a lot of really exciting stuff happening, particularly in academia around like agents that are very good at search specifically. And so that to me is quite promising. Now, that's not necessarily promising for like an explosion of new frameworks, to be clear. That might
Right.
be the
This,
opposite, right?
yeah.
That could be the
And there's
opposite.
no way to know. It's just, it's
Yeah.
interesting how what you really hit on that point, which is there are all new ways of doing things, and everybody is saying, I'm the way to do thing X and I'm the way to do thing Y.
Yeah.
Jeff, you kind of talked about, the hair on fire problem a few set of people have today that many will have tomorrow. What's an example of a use case that like really needs good AI search, good context engineering, and you kind of
Yeah.
can't accomplish this use case without that?
I mean, there's an interesting report from OpenAI maybe a week ago. I'm sure it hit the subreddit, which was like basically like, here are the use cases for ChatGPT. And if you look at those use cases, like 60% of them are very much search centric. Like they are like kind of search use cases, but like, obviously different nuance there, but like, they all have like search as kind of their core primitive. And so I think that actually like, in some ways you can think about like the vast majority or over 50% of like use cases for AI today like, are search. That might not be true long term as as AI becomes like more generative, but like we commonly see is like new ways of technology. The first thing they'll do is they'll eat what came before. And so like, the internet, what was the first popular use case for the internet? Or one of them, it was phone books. And you're like, phone books on the internet, like great, like we already have phone books, now they're on the internet. It's almost like, oh, we already have search, now it's better search. I think that like those use cases tend to grow really quickly in early adoption cycles, the early technological adoption cycles, because people already can like reason about them and understand how to use them because they've used something like that before.
An example of that's kind of what you mentioned, the enterprise search.
Yeah,
I want to go find stuff in my company, hook up a bunch of things,
yeah,
search.
yeah.
That actually,
Go ahead, sorry.
I was going to say that also, there's these two approaches. One is put them in a vector store. There's this other approach, which you kind of mentioned, but we get to clarify, which people are calling the agentic approach, which is like go hook up to a bunch of MCPs and make API calls. What's better when, or do they get used together?
I think it really depends. I mean, like you can use, let's say that, Google Drive has like an API to search, right? Um, you know, that may or may not be good for your agent to search. It doesn't matter if you use MCP in the middle, obviously.
Yeah.
Like the indexing approach that Google Drive gives you is purely lexical. Like you could not type a description of a document at a high level into the Google Drive search bar and get back a list of documents. And that capability might be, at least not today, right? And that capability might be very important for like your use case, for example. And so, like, I don't think you can always rely on the platforms to index and make the data available with you want it to be. Another thing we hear about all the time is GitHub. The GitHub API is always going down and it's slow and you get rate limited. And so, like, you have no control over your latency, you have no control over your availability, you have no control over your costs necessarily. It's just like has a bunch of hair on it. And so, like, if you're really serious about building something really great, you want to have full control over all those pieces, which may mean that you don't want to rely on like GitHub's indexing of code bases, but you want to go and do kind of like the scraping and indexing of code bases yourself and put them inside a database that you control. And so I think that like, I mean, MCP is great. We have an MCP server for Chroma. We're going to do more MCP stuff in the future. Like, I think that like the intuition that like search is just tool calls at the end of the day. And actually that like search is like the main tool call and actually search is like a meta tool call because first you decide like search for which tools you should call, in some sense.
Yeah.
Like I think that like that's totally true, 100% true, unquestionably. But like under the hood, under that API call, under that tool call, like how is the data organized? Is it organized in a way that you want? Does it give you the tools that you want? Is it fast? Is it cheap? Is it available? Like these are all questions that are so very important for building like production systems.
There's a question in the AMA that I'm going to make a little bit more general than the specific, but there's a question about Chroma, so I'm going to kind of fold it in. This is from Portuguese Fruit, and this person has a direct use case. So instead, I'm going to ask the question of what's your advice for balancing chunk size versus query time relevance? Is there a sweet spot? Is it always it depends? And how does Chroma DB specifically handle fast retrieval while preserving document structure, such as hierarchical relationships?
Hmm.
So again, this goes straight into everything you've been saying, which is
Yeah.
it's all about retrieval, it's all about search, it's all about that data.
The first thing that I'll say is there's no panacea. And actually, the benchmarks are often incredibly deceptive. We did a technical report earlier this year. It's on our subdomain research.trichroma.com. We did it with weights and biases, and we looked at their query distribution and looked at their like chunk distribution, and we synthetically built a golden data set so that we could now have like verifiable like query chunk pairs. So given this query, it should resolve this chunk, right? This is how you build a golden data set. Given this input, you should yield this output. And then you can test like, okay, with this embedding model, how many matches do I get? With that embedding model, how many matches do I get? And like, you can empirically test and iterate your system. By the way, without LLM as judge in the loop, right? So it actually can be very like cheap and fast to iterate versus if
Right.
LLM is judge in the loop, it's like going to be slow and brittle and expensive. So golden data sets, I think everybody should build them. They're easy to build. You should use the notebooks and the code that's provided in that like technical report. And like basically the intuition here is like with a little bit of work up front, you can teach an LLM how to write very good synthetic queries for your corpus. And so there's no reason that like, I have to have a kind of a paintbrush, which is like, this approach is
Right.
best for everybody. Like you should go measure it yourself. I'll give you one quick example. On the MTEB, which is a common benchmark for retrieval performance, a model from Gina AI was the best for English by far.
Mm,
What I found was that model was actually the worst on the weights and biases data set. Weights and biases, they were using an
yeah.
OpenAI model. In our testing and with them in collaboration, we showed that like actually an embedding model from Voyage AI was by far the best for their use case. And it wasn't a small gap. It was like, I forget the exact numbers, but I think there were like 20 or 30 point spread between like the worst model and the best model. And so this can make like a really big difference. And the same thing applies to chunk strategy, right? Like
Right.
I think the same thing applies to chunk strategy. It does depend because like this is like your domain knowledge. And especially if you want to do single stage search, you get one shot, right? And so
Right.
like you bet that one shot had better work. Now, if you're doing agentic search where the model can continue to go back and query again and again and again and adjust its query, then like maybe like the indexing kind of correctness matters a little bit less. Also, the agents, if an agent is searching over and over again, the agent can start to intuit and build a structure, implicit structure over the data that doesn't have to be encoded in the data. So I'll give you one
Right.
example of this. Like if you ask, what did my mom eat for breakfast yesterday? Like that could be encoded into a graph database. Like literally, I think another Redditor was asking about this, right? That could be
Yeah.
encoded like a graph, like a Neo4j, like a rigid KG triple store RDF graph. Or the agent could be like, okay, great. First, I need to find the user ID for mom. Okay, great. That's 4. Great.
Hmm.
Now I'm going to query the food collection with this time interval where metadata user ID is 4. Now you've like implicitly at query time found a structure in the data that doesn't have to be in the data at ingest time.
Right.
So this is, I think, again, you're always in computer science software, we're always trading like query time performance for ingest or indexing time performance,
Yep.
action time performance. But the more that you put your data into a given structure at ingest, the more that you fit the queries that you will support to that data structure. And there's something powerful about like being able to impose or sort of find or reveal a data structure at query time. And so I feel like I'm going down a bit of a rabbit hole now, but those types
No,
of really
I'm
interesting.
thinking it's a RAG system for your RAG system. What you're talking about, the graph and restructuring your query to then do that search. It's interesting.
Yeah.
Hey Jeff, there's kind of a ton that needs to be done. How do you think about that? How do you prioritize stuff? And then Chroma is open source. How can the community kind of contribute and help out as well?
Great question. I mean, our North Star, yeah, I think again, there's like kind of the long-term vision of what we like want Chroma to be. And it goes back to that like reason we started the company, which is like, and the project is because like we want to make it easy to build great stuff with AI, like full stop. And it's gonna take a long time to get there. We can kind of like see through the glass dimly. It's not super clear exactly what the shape of that is right now. But like the problems that our users are facing today, like those are very obvious. And so like we're very much like user led. We're rolling out this week full support for sparse vectors. So you can do BN25, you can do BN25F, you can do Splade, you can do TF-IDF. You can do server-side ranking where you can like do dense hybrid search, like dense and sparse together with a custom mathematical function to determine the ranking. A lot of this stuff also, by the way, can be determined by the LLM, right? So like actually the LLM can decide at query time whether it wants to weight dense versus sparse more or less, which is like really cool. And there's a bunch of other stuff like that we're working on.
That is cool. Yeah.
Yeah, there's stuff like that we're working on. And it's really again in the pursuit of like giving our kind of community better tools to build more powerful applications more easily, and giving them their agents, their AI agents, also great tools to build great stuff. So that's our North Star. In terms of getting involved, if you're like a Rust developer, there's a strong chance that you can contribute to kind of some of our core infra. Chrome is written in Rust for performance reasons. And then if you're a Python or JavaScript or Ruby developer or other, we have like first-party clients for all those languages. And we support like embedding model adapters. And soon we'll have to also support sparse vector kind of adapters as well. The dense versus sparse. We're thinking about like it's very likely that we'll fold in like kind of re-rankers also into that like API surface area. And so like, these areas are very good for the community, I think, to like get involved and engage.
Awesome. Uh, Jeff, thanks a lot for joining us. I know you're gonna be around on the RAG subreddit and kind of the AMA answering questions.
Yeah,
So I'll let you kind of go and do that. And if folks have questions, jump in, add them to the AMA post. Thanks a lot.
Thank
sounds
you.
great. Thanks for having me. I'll be refreshing the Reddit AMA all day here today and looking forward to chatting with you all. Thanks.
Awesome.
Awesome.
Thank you.
All right. Thanks, guys. Bye.
Bye bye.
Bye.